Okay, the topic for today is more right triangle trigonometry and using right triangle trigonometry to find some unknowns. We'll get started with that. First problem is number 17. Now, problem number 17 gives us this information. Sine theta is 8 over 17, and cosine theta is equal to 15 over 17. Given that information, we're asked to find the other four trigonometric ratios. First, it's probably helpful to draw a triangle. Now, the triangle is going to have signs of 8, 15, and 17. 17 is going to have to be the hypotenuse. So we'll draw a triangle like this. 8, 15, and 17. Now, sine of theta is 8, 17, so the theta is going to have to be here because sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay. All right, well then tangent of theta, if we look at this, opposite over adjacent, that would be 8 over 15. Cosecant is reciprocal of sine. Secant, reciprocal of cosine. Cotangent, reciprocal of tangent. Okay, number 19. Same directions. Given information, sine theta is equal to 1/3. Now they say cosine theta is equal to 2 squared roots of 2 over 3. All right, well, let's draw a triangle. 1/3, 2 squared roots of 2 over 3 is bigger than 1/3. But we try to draw triangles reasonably, but we'll do this, okay? Okay. Let's say that this side is 1, that's 3, and this is 2 squared roots of 2. All right, and this time I'm going to put the theta over here, and I did this on purpose to make sure that you know that angle can be anywhere, but if the sine theta is given as 1 over 3, the opposite has to be the 1. The hypotenuse is 3. The 3 is on the bottom of both sine and cosine. That is the hypotenuse. Okay, let's look at the triangle. Tangent, opposite 1 divided by 2 squared root of 2. All right, now we're not going to leave that square root of 2 down there. We're going to rationalize this by multiplying the square root of 2 times the square root of 2. So tangent, I'm going to put that right down here. The square root of 2 up here. 2 times the square root of 2 times the square root of 2 is 2, so that will be over 4. Cosecant is the reciprocal of sine, so that's 3 over 1, or just 3. Secant is the reciprocal of cosine, so that will be 3 divided by 2 times square root of 2. And again, we will rationalize that, multiplying this by the square root of 2 over the square root of 2. So that will give us 3 square root of 2. 2 times, again, 2 is 4. Cotangent will be 4 divided by square root of 2. Now we'll rationalize that. Square root of 2 over square root of 2. This will be 4 times the square root of 2 divided by 2, which will reduce down to 4 divided by 2 is 2 times the square root of 2. Now that was a little bit more difficult problem. Here are the answers. Well, those were given to us. That's an answer, that's an answer, that's an answer, and that's an answer. That took a little bit more work. Okay, number 21 is next. Now the directions here say, given sine of theta is equal to 6/7. Use the Pythagorean identity, it says, to find cosine of theta. All right, well, we have to talk about what the Pythagorean identity is. This is the Pythagorean identity. it says this. Sine squared theta, oops, make that a square. Sine squared theta plus cosine squared theta is equal to 1. That's known as the Pythagorean identity of trigonometry. Now sine squared theta means, and I'll write this over here, that actually means sine of theta quantity squared. Cosine theta quantity squared. Now the reason it's written like this, sine squared theta, is to not confuse the square where it goes. If you put the square over here, you might square the theta value instead of squaring the whole thing. So traditionally the identity has been written this way. All right, but you can use it then. We can substitute for 6/7 here, squared. We don't know what cosine squared theta is because that's what we're trying to find. This is 36 over 49. Cosine squared theta is equal to 1 minus 36 over 49. Well, 1 can be thought of as 49 over 49. 49 minus 36 over 49. So cosine squared theta is equal to 13 divided by, whoops, 49. We take the square root, so cosine of theta is equal to the square root of 13 divided by the square root of 49, which is 7, and that is the answer. That's by Pythagorean identity. Okay. Now we're going to go to number 23. Send in my paper here. Okay. 23 says sine theta is equal to the square root of 39 over 8. Now the book says to do this by Pythagorean identity, and you can, but we can also do it a little bit differently. We can do it by triangle. Okay, if I draw a triangle and put the theta right here. If the sine of theta is equal to the square root of 39 over 8, that makes this side square root of 39 and that side 8. Now I can find this unknown side in the right triangle by the Pythagorean theorem. That's why that's known as the Pythagorean identity. So I can write the Pythagorean theorem, x squared plus the square root of 39 squared is equal to 8 squared. Now the square root of 39 squared is 39. That's 64. Okay, subtracting 39 from both sides, that gives me 25. X squared, I should say, is 25. So x is equal to 5. Cosine of theta. If x is equal to 5, that's adjacent over hypotenuse, which is 5/8. All right. Well, this is going to be the first time we use calculator to show you how you can check your work here. Okay, now in the next couple of days we're going to get into a bunch of the stuff that the calculator means. First of all, we probably want to operate in degrees unless otherwise told. So every time you check your calculator, use your calculator, put the mode button and check the degree or the mode and make sure you're in degree mode, not radian mode. We'll get to radian mode. Okay, so I am in degree mode and I'm going to leave it like that. Oh, I can find that angle, theta, by taking the inverse sine of the square root of 39 divided by 8. And I take the inverse sine, second sine of square root of 39 divided by 8. Okay, that gives me a degree measurement. Okay, so it says that this angle right here is somewhere near 51 degrees. Okay, that's what that's telling me. Okay, now I can store that. There's a theta right here on the calculator. You see, it's above the 3. So I'm going to store that in theta. Okay, now I have that in theta. Now the question was, what's the cosine of theta? Well, I can go ahead and type cosine of theta. And it says 0.625, math, enter, 5/8. All right, that's a way to check this type of work by grapher. Now you should get, I think, very proficient with checking your trigonometric work by grapher. It is very useful to be able to do that. And again, using the grapher is a benefit to you. Nothing but a benefit to you. All right. The next problem we're going to do is problem 49. Okay, now 49 gives you a triangle. It's drawn for you. And it's known as triangle A, B, C. Usually when we call it triangle A, B, C in trigonometry, C would be the right angle. Okay, so it gives you this side to be 250 centimeters and asks you to find A. All right, I'm going to additionally ask you to find C. I want you to use right triangle trigonometry to find both A and C. Now the book says only find A, or one thing. I want you to find two things. We're not going to do too many of these, so it's not that much work. All right, well, we have to look at what we have and what we want. Okay, we've got an angle, and we've got the adjacent side to that angle. Now we want the opposite side, and we want the hypotenuse. Now, all the time you're doing this type of stuff, you want to keep in mind SOHCAHTOA. Okay, let's concentrate on A first. To find angle A, we have an angle and we know the adjacent side. A is opposite. So what trig ratio involves the angle, the adjacent, and the opposite, and that is tangent. So we'll write this. The tangent of 37 degrees is equal to A divided by 250. We'll put the units in when we're done. Opposite divided by adjacent. Okay, now I can think of this as a fraction. I'll cross multiply. A times 1 is equal to 250 times tan 37. Now here is a hint. Don't find that tan 37 as a decimal amount and then write it down. Type this all in at the same time. Okay, watch. Now, I hope you can see this on the video. If not, do it yourself, and I'll say it aloud. 250 tan 37. Okay? It gives me the answer directly, and it is 188.4. And the units there are centimeters. Okay, now the directions say to round to the nearest whole number. All right, so we can do that. That is 189 centimeters, or pardon me, 188, I should say. 4 rounds down. Okay, now I ask you to find this other unknown. That's the hypotenuse. What trig ratio, and I'll put that in a box up there, involves the adjacent side and the hypotenuse? That's cosine. So we write cosine of 37 degrees. That doesn't look right. That's better. Is equal to the adjacent side 250 over hypotenuse C. Okay, this time I'm going to consider that to be a fraction. I have C times cosine 37 is equal to 250. To isolate C, I divide both sides by cosine 37. Not 250 degrees, just 250. We'll put the units in later. Divided by cosine 37. Okay? Back to the grapher. 250 divided by cosine 37. Now, I suggest you always close off your parentheses. The calculator doesn't really require it, but it's good to do it. Okay, so it says nearest whole unit. We will say that C is approximately equal to 313 centimeters. Okay, number 51. I'll slide up a little bit so my grapher can fit in. Again, we have a triangle ABC. And again, if a right angle is involved in a right triangle, in ABC. It's usually C that's given that. Okay, so we have a 34 this time here, and this time we're given the hypotenuse of 220 inches. Now the book asks for this B. I will also ask for that A. Okay, now we're going to look at, let's say, B first. We know an angle and a hypotenuse, and we're looking for the adjacent side. The hypotenuse and adjacent side is cosine. So we write cosine 34 is equal to B divided by 220. Okay, cross multiply. B times 1 is equal to 220 cosine 34. We type it in directly. 220 cosine 34. Okay, that is 182. All right, let's look for A. That's opposite, and we know the hypotenuse. So this is a sine. Sine 34 is equal to opposite A divided hypotenuse 220. Again, cross multiply. A times 1, 220 sine 34. 220 sine 34. 123.0, or approximately 123. Oh, these are inches. I should change that. Inches. Units are important. Okay. And 53. You draw the triangle backwards. Not backwards, but it shouldn't bother you any way that the triangle is oriented. All right, there's a 23-degree angle here. Again, triangle ABC. This is given as 16 meters. Now, they're asking you to find C, but I'm also asking you to find B. Now, I'm labeling opposite the side angle B is lowercase b. That's tradition. Okay, let me just slide this up a bit. I'm trying to stay in frame. Okay, to find C, that's hypotenuse. That's opposite from the 23. Opposite and hypotenuse is a sine. Sine 23 is equal to 16 opposite divided by hypotenuse C. Now we're looking for C. When we cross multiply this time, 16 times 1 is 16. That's equal to C times the sine of 23. Divide both sides by sine 23. 16 divided by sine 23. Okay, let's see. That should be in frame, I think. 16 divided by sine 23. Okay, 40.9. Or C is approximately equal to 41 meters. Now that makes sense. This number, seeing how it's at a hypotenuse, should be larger than that one. It's significantly larger because 23 is not a very big angle. So C should be significantly larger. Okay, to find B. B is adjacent to the 23. Okay, and we know the opposite side. All right, what trig ratio works with adjacent and opposite? That is tan. Tan 23 is equal to opposite 16 divided by adjacent b. Opposite. So katoa, tan is opposite over adjacent. All right, again, we cross multiply. 16 is equal to b times tan 23. Isolating for b, divide both sides by tan 23. 16 divided by tan 23. Into the grapher. 16 divided by tan 23. Okay, that would be 37. Okay, now that should make sense too. If this 23 is a relatively small angle, the B should be significantly bigger than that one, and it is. Okay. All right, well, there we go. And that's the last problem. So the assignment is section 5.2, numbers 18 to 24 even, and numbers 50, 52, and 54. And for these three, find both unknowns. Like we did in the examples, instead of just finding the one that they asked for, you find them both. Extra practice. Okay, the next class section after this one, I believe, will be after the weekend. So you guys have a nice weekend. And if you didn't sign up for the Google Classroom, please sign up. I'm supposed to check to see if everybody's getting the information. Now, I don't know if you guys watch these or not. I mean, some of them have been watched. I can tell by looking at YouTube whether they've been watched or not. Some have been watched over 30 times. Others have not. So if you're not watching them, you really should watch them. I know I'm a boring person, but you should watch the videos. Okay, we will meet on Monday.